design. Basically, when you are going to perform a research, when you're going to write a research paper, your thesis, your MA thesis, you may need it, right? So, and it is one of the steps there are a couple of steps that you would be learning in research design courses, and this is one of the steps of a research design. Now, the first step, for example, is the sampling design. As yesterday we were discussing in detail that how are we going to select the items that we are going to observe, right? And I told you that there are several ways, probability and non-probability techniques, right? So, and probability techniques are, I would say that mostly used, but it does not mean that non-probability techniques are not at all used. They are used equal, if you compare, because of the the availability of data most of the time. And one is method of selecting items to be observed, and the second method is related to the conditions under which the observations are to be made. Yani, I mean, how we can actually, what are those conditions under which we, observe our data? What are the, for example, do we need to do the clusters or the groups? Do we need to do the stratums? Do we need to do the groupings? Do we need to create the frequencies? So what are the conditions? What are the circumstances that are available? And the last one, which is important for us, is concerning with the question of how many items are to be observed, and how, not sorry, not it's not he, is the information and data gathered are to be analyzed. That, first of all, what should be the size of my sample, or what should be, or how many variables. You can take hundreds of variables, you can two variables. Today we are going to discuss about variables, what is variable, and the types of variable. Okay, that how many items that you are going to observe, and what are the techniques, as I mentioned yesterday. So as I was telling you, that today we use a lot of different techniques, a lot of different, what you call the softwares. We have Minitab, we have R, we have SPSS, we have Python, so different techniques. And this statistical design actually relates to that, which technique and how many items are you going to analyze, or use. For example, if your data is very, I would say very big, it contains like many variables, then of course it would be difficult for you to do analysis on, simply kind of very traditional softwares like, Excel, for example, or you might need, different techniques or different tools, or the equipments, like, you might need R, or you might need other software. So depending on what size of your data is, you have to choose, you have to select your methods of, analyzing that data accordingly. Okay, statistical method, and it will be more clear when we do some types. There are two types which are also mentioned in both of the books I have shared with you. You can go through in detail over there. Now, completely randomized design. Randomize, you already know random. Yeah, in a completely randomized design, all the experiments units are assigned, randomly among all the treatments. Okay, let's understand this without focusing much on the definition. Let's do one small example, and then we come back to the definition. Let's say you want to, I would say, we want to know that where a student or students can do better in library, at home, or cafe. Okay, so let's say you have a university, of 30 students. Okay, I'm just writing here, you have 30 students, and these 30 students are coming from, it's up to you, either you say university 1, or university 2, or university 3. It's it all depends on you, but the more your range is wider, the more it is better. So let's say you choose these 30 students from three different universities, University 1, University 2, and University 3, and then further you create three groups actually. So so three groups you create. G means group. So this one is group A, group B, group C. Okay, and each group, you assigned a task actually. So the first group, you make them sit in a library. Let's say I'm writing L means library. Okay, the second group, ask them to just study at home. So I'm writing home. Okay, and the third group, you ask them to go outside and read in cafe or parks or anywhere. Okay, so this is, I'm writing here just outside. Okay, so you can outside. So library, home, outside. Okay, now what you do, simple, you find the average, the mean. Okay, of all. For example, one student can study 10 hours, the other student can study 8 hours, the other student can study maybe 15 hours, depends. Likewise, you will find 10 different answers, 10 different figures. Someone can study at home like 5, someone can 7, someone can 8, and then you will find the mean of all these three different groups. Okay, likewise the same, and then you compare, and that is called completely randomized design, okay, of sampling. That how you create the groups. So it looks like, what we discussed, much just an extension of that you completely randomize, but by creating groups, and each group you assign some, task to your groups actually, and each group. So how effectively, it can give answers, or by, it depends on the number of students, that how many students you are actually selecting, right? If you're, as I have mentioned, the bigger data, the more accurate answers. And by the way, we will be, yesterday we were discussing about that mean is equal to mu. It is true, or it is true at the same time not true. So we will be actually exploring this in inferential statistics, okay, from next to next week actually. In my third week, we would be, our discussion would be on this, because okay, so I hope it is clear that randomized design. The next one is randomized block design. You're going to create block A and block B. So I'm going to write here block A, okay, block B. And in block A, we are going to write female, okay, and block B, we are going to create male, females and male. And again, the same thing, group 1, group 2, group 3. Okay, here, let's say group 4, group 5, group 6. Okay, so now we have reached the same thing, right? This one. So earlier we did not have blocks, therefore we had just three groups, different groups from the same population. And but here we have group blocks, and then we have further division, and then again we are going to assign them the same thing. Library, what was next was home, and the third one was outside. Likewise here, library, home, and outside. And then what we are going to do the same thing. We would find the mean, average of all, and then we compare our results, that which design actually is the best, which are you getting my point? Descriptive statistics we discussed yesterday. Okay, we'll just directly come to the point called the measure of. This is also called actually a measure of central tendency. Okay, or a very important part under descriptive statistics, measure of central tendency. So from the word central, you must be getting an idea that I'm talking about something central, something mid, or something the midpoint. So what is descriptive measures that indicates where the center, as I have mentioned, or most typical value of data set lies are called measure of central tendency or measures of center. Measure of center often called averages. Yesterday I was discussing that, we have basically three types of averages. We have mean, we have median, and we have mode. Okay, all of them are averages. Okay, but how they are different? Let's say this is the salary. This is the salary of employees, or of a particular company. So we have $300 a month, 300 $940 a month, $400 a month, $450 a month, $800 a month, $450 a month, okay, and $1,050 a month. So we have different salaries, of different employees. Now, first of all, we have to find the average of the what we call the mean. Since it is a sample, or I assume it is a sample because it is not mentioned. As long as it is not mentioned, you can assume either population mu or sample mean, because it does not actually affect the question until and unless it is mentioned. Okay, so here it is silent about the nature, so we can say it is sample. Therefore I'm writing sigma x divided by n. So what I'm gonna do, I'm gonna the total of each, and this is my x. Okay, this is my x, is my variable. Okay, variable. What is variable? We will come to that point. So this is, let's assume that this is variable x. Okay, so what we are going to do, we are going to add all of them, 300 plus 300 plus 300, right, plus 940 plus 300 plus 300 plus 400, okay, plus I think again 300, yeah, plus 4, I think 400, plus 450 plus 800 plus 450 plus 1050 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 numbers. Okay, so you will add all of them, and that would be called sigma. Sigma means, I told you yesterday, total. So it would be like total of x divided by n. N is number of observation. Number of observation. Okay, number of observation. Okay, so one student has given answer 483. Okay, whatever whatever the answer. Now, so this is called the mean. So mean is also average, but let me to another average, which is called the median. So just keep it in mind, mean, and then we will see the difference between. Then why do we need to calculate? Let's look at the calculation first, and then we will come to the analysis. So look at the median. So median is actually called the midpoint. The midpoint. For example, if you have this, let's say, so what is the midpoint? Somewhere here. Yes or not? So somewhere here, it would be the median. Okay, so what we do in median, the formula of median is actually n plus 1 divided by 2. N plus 1 divided by 2. Okay, so what is n? N is again number of observation. NUM, number of observation. Number of observation. Okay, and what is this observation? Actually, this is our variable, our x. Okay, so first, what do we have to do when it comes to a median? We are going to arrange in an order. Okay, let's say, for example, 300, 300, 300, then we have 940, then we have 300, and then we have 400, then again we have 300. So here there is no order. So what in median, always put in an order. Either it should be in descending order or ascending order. It does not matter. Okay, what matters is that it should be in an order. Okay, so let's put it in an order. So it is 300, 300, okay, 300, again 300. So we have, 5, 300, and 6, in fact, 300. And then we have 400, isn't it? If I, okay, 400, and again 400, I guess. Let me put commas, otherwise it will not look. Okay, 400 again. So how many 400? 2 400. And then 450, and then 800, and then 400. Oh, again 450. So we had two 450. Sorry, here. Let me just write one more 450. And then again we have 800. Okay. And then 940, I think, and then 1000 and 1050. Okay, so how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. 1, 2, 3, 4, 5, 6. Okay, now what we do, we apply the formula. So now they are in ascending order. Okay, they are in ascending order. Ascending order. So our formula of median is n. So n is 13. 13. Okay, number 1, 2, 3, 4, 5, total 13 plus 1 divided by 2. So it is 14 divided by 2. It is actually 7. So 7th in ranking would be our median. So 1, 2, 3, 4, 5, 6, 7. So 400 is actually our median. So 400 is the midpoint. Midpoint. For example, I have this pencil. If I divide this pencil from the midpoint, so it will be, so both parts would be equal. Yes. So 400. What does it mean actually? In the previous question, I mean, in the mean, the average salary was somewhere, how much did you tell? 483 something. The average salary that each and every guy was on an average getting 480. How much he told me? Yeah, 483 on an average, each and every guy. Okay, get my point or not? Now, but look at the median. But in median, the midpoint, it's also an average, but it's different from mean actually. It says that no, the average salary is not 483. It is actually 400. Okay. What does it mean? It means that your average salary, your midpoint is 400. So all these people who are the right side, the right side of 400, are actually getting somewhere close to 300, between 300 to 400. And those who are falling at the left side actually getting 400 to 1050. Okay, and the midpoint, but is it the average actually? Which one is accurate? That we have to discuss. Now, the next is called the mode. So what is mode? Mode is so simple. We don't have any formula. We call it mode. We don't have, it is also written as Z. So median is, I forgot to tell you that median is written as MD. Okay, mean is written as X, and mode is written as Z. But Z word is actually used for other symbols also, like Z score, which we would be learning later. Okay, so don't get confused when you look at the book. Okay, so it is also called Z. Okay, so mode is actually the largest, the highest frequency. For example, let's put our data X, okay, 300. And then what is the next value? The next value is 400. What is then? Then we have 450. What is then? Then we have 800. What is then? Then we have, I think, 1050. We have 940 in between as well. I'm always forgetting 940. Okay, because it's written here. And then we have 1050. Okay. Now, if you look at the frequency, the how many times actually, or how many people are there who earn $300? So I can see 1, 2, 3, 4, 5, 6. So the frequency, okay, is 6. Number of repetitions, yeah. And 400, how many? I think 401 and 2. And what about the 450? How many? 450, just one. 800, just one. No, 452, sorry. What about 800? Just one. 941, 1051. So which number is in the highest frequency? This one. Therefore, 300 will be our Z. Okay, 300 will be our Z. Z means the mode. So guys, now what you have, my answer says 474, but you can check, no problem. Look at here, the analysis. We found averages. Mean is an average, median is an average, mode is an average, but in all averages, we have different answers. Mean says the average salary is 474. Median says the average salary is 400. Mode says the average salary is 300, because mode has different. Mean is 484. Okay, no problem. It could be 484, no problem, maybe. Okay, so what is the most reliable answer? I tell you the drawbacks of all, first of all, before we can discuss the benefits. The first drawback of mean, is very sensitive. It covers the least and the highest also, the lowest figure as well as the highest figure. When we look at this data, when we look at this data, one thing is clear, without doing any analysis, that 300 is actually somehow the average salary, 3 to 400, because there are 6 people we can see, who are getting $300 a month. So it is clear that most of the people, but there is one guy, just one guy in entire company who is getting $1,050 dollars a month. $1,050 a month, but he just one guy. But me, because of the means nature, mean is also considering it as it is a part. It is definitely a part of the average, but it's just one. Okay, now so this is the drawback of the, as I have written, the reason that the mean is strongly affected by the few large salaries in data set. Few large salaries. Which are these few large salaries? 1050 and 940 and 800. That's all. Just because of 3 large salaries, the entire mean is affected. Now, how about in general, the mean is sensitive to extreme, to very large, to or very small observation, where the median is not. But median is not affected. Why? Because median is the midpoint. You must have seen when the highway is being built or constructed, the highway, the builders, they divide and they write their M, sometimes the midpoint, for example, the midpoint. So if you look at this midpoint, you say, wow, this is the average, but this is actually not an average. This is just a midpoint. Maybe we have extreme values on the left side, or maybe what you call the very lowest values on the right side of the data, for example. Okay, and next one is we have a mode, because mode completely actually what you call reject or deny the highest, because it depends on just if, for example, you come to my university and you say, hey, I want to work in that university, and this is what we do, right? We don't look at the offer letters or invitation letters of the company. What we do, we simply ask our friends, hey, if I apply in this company, how much I'm going to get a month, and he gives an answer, oh, you can get this and that, then other friend, then the other friend, and if I have my 5 friends working in a particular university, and if they tell me that, what, the salary is like, somehow $100 a month, and I say, oh, the average salary, what is $100? Maybe there is a guy who is getting $50,000. It's just $5,000, $2,000. We have different uses of mean, median, mode, because I know the next question would be coming to your mind, that so can we use any of them? No, we cannot use all the time. Depends on what we are doing, and we will be looking at all these things in future. So what is standard deviation? Now we are learning all these concepts in pieces, Okay, but when we have data and when we are going to analyze the data, all this knowledge will come onto one page. Yeah, and then and therefore you try to just learn all these concepts, because these concepts are going to be repeated time and again. Okay, either you are going to learn econometrics in future, or mathematics, or whatever, or analysis or research methods, whatever the subject, you are going to look at these things time and again. In fact, they will not leave you. Okay, so standard deviation, you can see from the word itself, deviation, how much my mean is deviated, my x is deviated from the average. Let's again look at this question. Let's look at this question. There is a guy A, okay, or say, let's say guy C. This guy, he wants to know that his salary, we know $300, and he says, hey, how much I am away from $1,050? How much deviated I am? Okay, his salary is 400, his own salary. So he, it's very practical actually. Let's think practically. Sometimes when there is a problem about the salaries, in the institution, so one does not compare with other, but they compare with the average. For example, if I have problem, if you have problem in future, you may not go to your boss and say, look, this guy is getting this much and I'm getting, you may say on an average, the salary is given this much and I'm given this much, for example, because your boss may reply, hey, look at his qualifications or her qualifications. So you compare with average. So here this guy says, hey, the mean, for example, 84, the mean was 484 and his salary is, let's say, 300. So what he says, that how much deviated I am from the average. Okay, my salary is $300, average salary is 400, so 184 actually dollars I am deviated, I'm away from the average salary. And if I compare myself with this guy, so you can see 1050 minus 300, something, I think $750. So deviation means the how far you are from the average, how far you are from the mean. I give you a very practical example. Let's say I have a class. Okay, in my class I want to know the average height or average score. Okay, let's say average score. And so I asked my first student A, she got out of 10, 7. The B student got 8, C student got 9, D student got 10, and E student got, let's say, I don't know, 8.5. Okay. And the other student, there's a F, he got 2, G got 0, G got 0. This is the scoreboard, scorecard of my class of statistics out of 10. If I find the average, so what would be the average? What would be the average? Can you tell me the average? Any one of you? Make it just simple. Can anybody tell me what is the average of this quickly, or I have to solve myself on my. So I request all of you to please have your pen, copy, and calculator if possible. Okay, 6.
Average is 6, I think.
Okay,
the answer is 6.
Okay, so
Yeah, 6.
let's say 6.36. Okay, assume that 6. Assume that 6. So let's say, for example, the mean, let's say my data is ranging from 0 to 10, because the minimum value is 0 and the maximum value is 10, isn't it? Or we can even put 15, no problem. 15. So the first value, the A, got actually, and then we can like, for example, let's say 0 to 5, 0 to 10, okay, 5 to 10, and 15. And the average salary will be somewhere here, isn't it? Because this is 6.37, so somewhere would be here. This is my actually mean, right? And how about if I want this guy, for example, A is getting somewhere here, 7, yeah, because this would be A. So I want to know that how he is far from the mean. How is far from the mean? Likewise, B, 8 here. Okay, this is my B. How much far from the mean? This is my average, sorry. This is my average. How much this is far from the mean? This much far. This much. Okay, likewise 0. Who got the 0? 0 lying here, average lying here. He is this much far from the mean. Are you getting my point? So standard deviation is always a calculation that how deviated you are from the mean, but there is a problem actually. Practically, if you think, for example, if I want to know the average height of, so if I want to know average height, let's say the average height, the same, let me just draw the same kind of line. Let's say that the average height is 170, but there is one student whose height is 140 lying here somewhere. Okay, student A. So how far he is from the average? Average is minus 30. Average is minus 30. So can his height be in minus? Now, simple question. Height cannot be in minus. Yes. Okay, he's far from this difference. So how we do actually? So this, and when we have such diverse data and such big data, how do we do or deal with all these problems? Okay. I have a question, already, because when you have small data like 3, 4, 5, 6, that's okay. But when you have big data, how you are actually going to deal with? So as we know that standard deviation is of population and standard deviation is of sample. So the population standard deviation, as we know, is actually written as this one, right? This one, and this standard deviation is written as simple SD. So the formula would be sigma, and why this formula and from where this formula is coming, I will come to that point. Sigma x minus mean whole square divided by n under root sigma x minus x, because this is mu, so it should be mu. So here x minus mean whole square divided by n minus 1. The standard deviation of sample and standard deviation of population, they are two different things. With the help of this standard deviation, I can also know about the dispersion of my data, how dispersed your data is from this point to this point, how dispersed, and with the help of that standard deviation, I can also predict, I can actually expand my data with the help of this small concept. For example, let's say, and here, let me give you an example of Tokyo. Okay, that in Tokyo, there are 5 shops, pizza shops, and Tokyo has just 5 pizza shops. I think this is, very, I think 60s, or I don't know when pizza came up, 1780s, time, 1970s or 80s, when only 5 pizza shops. And since it is only 5 pizza shops, and I want to know the mean of the pizza, the average of pizza price, because I have 5 different options, 5 different shops, but and each of them, because of that each shop has its own price. So I want to know what is the average price of pizza. And since Tokyo has just 5 shops, and so this will be my population, isn't it or not? Do you agree with me or not? Because Tokyo has just 5 shops. So
yes, it will be population.
Yeah, it will be population. So let's say that pizza is my x. I assume that this is my variable. Okay, this is my x, and I'm writing here pizza price or pizza shop, whatever you like. Let's say pizza price. Okay, Now I am having here shop 1, shop 1, shop 2. Okay. Likewise 3, likewise 4, likewise 5. Is it 4? I think correct, isn't it? Because we don't use these numbers. Actually, I have forgotten, honest. Okay, so shop 1, let's say the price of pizza is actually the same thing. Let me make a little bit small so that I will have some space. Otherwise, we will have space problems. And pizza, PP, pizza price. Okay, PP. So the first shop $2, assume that. The next is, I think, let's say 4, 5, okay, and 7, and this is my population. Therefore, I have to calculate the mu, not the mean. The only difference. Calculations the same, concept different. Okay. Afterwards, very good. Yes, calculated the mean. You're gonna help me like this, yeah. So what is the total of x? This one.
21.
21. Yeah, 21. Yeah, 21. And now what we are trying to know, mean, we have to calculate. This is going to be sigma x divided by mean, and one student has already given. Thank you so much. It's 21. It's 21, isn't it? Mean is 4.2. Very good. 4.2. So we have already got the mean. So how far the first price of pizza is far from the average? So 2 minus 4.2. Okay, very quickly. 4 minus 4.2, 5 minus 4.2, 7 minus 4.2, 3 minus 4.2. Okay, so this is going to be my x minus, you can say, the mu. Actually, I have to write mu because this is okay, population. Now, how much it is? 2 minus 4.2. I think it's going to be minus 2.2 minus 0.2, isn't it? 0.8, 0.08, and no, 0.8, isn't it? Correct, isn't it? And next is 7 minus 4 is 2.8, 3 minus 1.2. Okay, now if you actually calculate the total of this, what do you find actually? And if I want to know, hey, on an average, the price of pizza was 4.2. I want to know on an average how much you are deviated from the mean on an average. So for this, what we have to do, we have to add, and then divide it by 5, because there are how many observations? 5 observations. But when we do this, actually, what do we find? We find that the answer is 0, because this is minus 2.2 minus 0.2 minus 1.2, and the answer is 0. Is it possible? Is it possible that on an average you are 0? You are far, the average is 0. No, it's not possible. So what are we going to do? We are going to use a simple mathematical technique, which is called just square it. Okay, so I'm just erasing it. I'm just erasing it.
Professor, can you repeat one more time why you are saying that the answer is 0?
No, because you do the calculation minus 2.2 plus, because you have to add. I'm asking for this sigma x minus, mean or mu. You get my point? Yeah, so when you do this minus 2.2 plus again minus 0.2 plus 0.08, 0.8 plus 2.8 plus bracket minus 1.2. When you solve this, you get the answer, this 00. So which is not possible. So what we have to do in order to get rid of this 00, we are going to actually put the square. Okay, now I'll tell you how it works. So when you do the square, it's simply 2.2 multiplied by, square is minus 2.2 multiplied by minus 2.2. It's going to be 4.84. So we get the answer in plus. So if you ask me the benefit is that we have got the answer in plus. So we got rid of minus. But does it solve our problem? No. Let's do this. 0.02 multiply 0.04, 0.8, 0.64, 2.8, 8864 to the 456. Okay, So this is going to be 7.84. Okay, and the next, if I am wrong, if there's a mistake, please let me know. Okay, and the next one is 1.2 is 1.44. So all answers are in plus now. And when you do the total of this, we got 4.84 plus
14.8.
10. Very good. 10. How much?
14.8.
14.8. Okay. Now we have got this 14.8, and when look at the formula, very good. 14.8. Look at the formula. The formula is, I think I need space. Can I write here somewhere? Okay, let me continue here. Okay, let me try here. Okay, so this is my formula is of standard deviation is 14 point, which one is sigma x minus mu whole square divided by n. So now I got this. This is 14.8 divided by number of observation 5, and I'm gonna put square root. Now you can ask me a question like, Kashif, why have you put square root? Look, my logic is so simple. If I have used square, why I put square root, sorry, square, but I got the answer in plus, but this was not something I was supposed to do. So I had to get rid of this 2 also, this square also. And in mathematics, how can we get rid of square? Just by putting square root. Yeah, thank you. So when we put square root, again we will get the same answer, 2.2, for example. Yeah, 2.2, but in plus. So do we understand the step? We had answer in minus 2.2, which is not possible, right? So what we did, on an average, our answer was 00. But in general, we know that the average price is different from each other. And when we try to learn how much each pizza price is different from the average pizza price, we found the answer was 0. So we said, hey, there's a mistake. So with the mistake, we got the answer in minus. So what we did, we put the square, but we put the square, and that's why we have to get rid of it. To get rid of it, I put the square root. And when you put the square root, the answer you are going to get is, one student has already given, let me see, 2.72. Let me find 14.8 divided by 5. I think the under root is 1.72. No, 1.72. Tilak, yeah, Tilak is right. Yeah, 1.72 or 73. That's correct. So this is called actually the standard deviation. Now I have got the answer that price of pizza is for how many standard deviations actually? 1.73. But now look, the language is changed now. My language is changed. My language, earlier I was telling that, how many points or how much you are deviated from the mean. Now I'm telling how many standard deviations you are far from the average. What if we have sample? In case of sample, we use n minus 1. Okay, so instead, in case of sample, it would be 5 minus 1, and it would be the same question but divided by 4. Divided by 4, right or not? And therefore, now you may ask me this question, that why we have put n minus 1, because again we will be covering this later, because it is about biased or unbiased data, which we haven't covered yet. Okay, so when you put it's a sample standard deviation, you remember always n minus 1. When it is population standard deviation, always capital N. Clear or not clear? Yes, Jarkin.
I'm sorry, I just
confused a little bit. Where we get this 1.73?
We get with the help of this formula. Rakin, here you can see, do you understand this formula? Did you understand? Okay, very
Yeah.
good. Okay, did you understand how we got this 14.8?
Yes.
Very good. And then what we just put this value, okay, in formula. So the formula is, again, I'm writing here, sigma x minus mu whole square divided by n. And here this value we got 14.8, and n is
Correct.
number of observation 5. You just do division. It is, let me see, how much is this? 14.8 divided by 5. Now you got
2.96.
2.96.
2.96.
2.96, and the square root of 2.96 is actually
Okay.
1.73.
Okay.
Okay, very good.
Yes, thank you.
Welcome. Now you must have done what you call the investment management, the stock markets. You must have done before stock markets, and if you go to the Google Finance or Yahoo Finance or any Dow Jones, you would find that they also list standard deviations. Always just go right now, you go and you check that they mention standard deviations of each stock, each share. Why? I tell you. So I'll give you some more questions for practice. Please don't forget it. We have to come back to these calculations. Let's say you have two players, player A and player B. Both are very good. We want to make a team, okay, and we decide to select both of them. But our problem is that we have to select only one, because 10 have been chosen already, selected already. So we have to select one player. Okay, so what we do in general, generally we go and we see, hey, what is the average, the goals you hit, in every match. So there are two, as I said. Let's say this guy on an average is hitting 3 goals, which is too much, but just assume, and the B guy hitting 2 goals. So when you look at this average, you say, hey, just go and pick up this guy, because look at his average, 3 in every match, but it is on an average again. And it's as compared to B, as compared to A, B is relatively, making 1 goal lesser than A. So if I ask, a normal guy, he would say, okay, go and select the A without any, question. But then we further interested in knowing that, hey, how much is deviated from the average. So for example, this guy's standard deviation, let's say ST 1, and this guy's standard deviation is also 1, for example. So both are, so what does it mean? Okay, so his average is actually 3 minus 1 to 3 plus 1. So minimum goal he makes 2, and the maximum goal he makes 4. So actually 2 to 4 he can do, because he has deviation as well. What is this deviation? Let's say, for example, I have 2 students in my class, and one student is one day she just gets 100 out of 100, and the next day she gets 0 out of 100. But there is another student, very constant, and she's always getting 90, between 90 to 100. So if you ask me that, Kashif, which is the good student, the better one, and I would say the student B, because she is constant, actually, not very much deviated highly, or likewise his is 2 minus 1 to 2 plus 1. So 1 2 3. So minimum 1, maximum 3 goals. So from this, again, A looks good, that you say, hey, still. But there could be a scenario where you find that B is actually better than A. Let me take an example. Sometimes when you are in stock market, you are invested in in stock market, you want to buy some stocks, and you see that there's a company, let's say Apple, Apple shares are constantly increasing the price, the market value, and you say, wow, look, let's buy. But when you look at the last year and before last year, you found that this company was doing very comparatively very bad, actually. So would you like to buy the share of a company who is very volatile? Would you like to have a player in your team who is very volatile? Would you like to have a student in your class who is very volatile? No, of course not.
No.
Yeah, so that's why standard deviation also helps us, to know the volatility, the variations, and that's why we call standard deviation under the variation. Okay, so I have another question here, question A and B. I mean the player A and the player B. Okay, you have to select one of them. Okay, the mean is 3. Okay, and the second player mean is also 3. Okay, so you can say, hey, have anyone, because both of their average is the same. But at the same time, when I'm asked, hey, what is the standard deviation? So you say, hey, 1 and 2. And then when you learn that 3 minus 1 and 3 plus 1, so it is going to be 2, 2, 4. And this one is going to be 3 minus 2, 3 plus 2, 1, 2, 5. So 2 to 4 and 1 to 5. You can say now interpretation. You can say, hey, this one is maximum hitting 5 on an average, but there's a risk. You know what? The risk is 1. But on the other hand, this guy minimum 2, but maximum lesser than the B1. I mean the B player. Okay, now it's up to you. Would you like to buy, or I mean have this player or not in your company, in your team? What I was trying to say, couple of minutes ago, that this standard deviation actually helps us to know the dispersion of data, that how your data is dispersed, how large your data is. For example, let's say that my mean is, for example, my mean is, let's say 5. Okay, my standard deviation is 3, for example. This is 3. Okay, if I want to know, hey, can you please tell me that guy A, how much he is far from the mean? So you can tell me in standard deviations also. You can say this guy is actually 2 standard deviation far from the mean, or 3 standard deviation far from the mean, or 5 standard deviation far from the mean. So 5 multiplied by standard deviation, and you can tell me the figure, and that this much you are far from the mean. We will be learning this in detail in our next classes. Okay, when we will be learning about standard error. Okay, in
Professor,
yes.
just for clarification,
Yeah.
the example with pizza was about standard deviation in population, right?
Yeah.
And the example with players was with standard deviation about the sampling, right?
Yes.
Okay, thank you.
Welcome. And one more thing, that why we call it population, because I assume in the beginning that Tokyo has just 5 shops, and that's why it is called population. And let's say if Tokyo today, for example, I'm sure today Tokyo must be having thousands of shops, and if I take 5 shops from them, it would be my sample, simple.